Hey, welcome everybody to DEFCON 1 Science. It has been a long time since we had one of these. Mostly because, things have been going on, so we really haven't had a chance to have a DEFCON 1. But hey, you know what? If we're going to have a DEFCON 1 Science, we might as well have, like, the best of the best come on, right? So let me just make sure that you guys can actually hear me again. I'm not doing this as NDI through Skype. I'm just doing it as desktop audio and bringing everybody in. Trying a little bit of things differently, see if that works. But let me know if you can hear us. And let me introduce my co-host here, Landon Curt Noll, the brilliant, erudite Landon Curt Noll.
Good morning, good afternoon, or good evening, depending on your time zone, latitude, and perhaps even attitude. And hello from your friendly secular astronomer.
It's good seeing you, man. It's been a while, although it hasn't really been that long.
but the universe keeps going on and showing us even cooler stuff. So we've got a lot to talk about.
Yes, we do. And the next, let me introduce. Oh my goodness, I'm so happy that she's back. You guys don't remember Astroathens, Athena. I'm just going to call her Athena. Not doxing her. That's what she goes by, people. But she was on a while back, and man, it was just amazing. So just having her come back again, her channel has been full of like amazing videos, like general relativity she just did, and she talked about science. And I got to tell you, she can put up a backdrop in a matter of like 16 seconds. So
I thought she's really out there in space.
You guys don't even know what we just witnessed with her. She went from like nothing to this beautiful mural in a matter of seconds. But anyways, Athena, welcome back.
Thank you. I'm super happy to be back, and I'm really happy that I had some tape to hang up my mural. Thank you. I thought I needed a hammer, but
it looks like a green screen, but it's not. That's legit.
Yeah. No, I love it. I'm happy I got to put it up for the show.
So I got your link in the video description. So before anybody even does anything else, go subscribe to her. Go check out her channel. We got to get her some subs. We got to get her. She's like, it's like 6K now, but we got to get her to
10. Thanks.
Yeah. Do you want to tell me about your channel before I introduce Dr. Kroon here? Although everybody knows who he is anyways. But,
yeah, totally. Well, I actually decided to start a channel all about astrophysics and space news, but trying to make it in a really fun, quirky way for people who maybe don't have a background in astrophysics and want to learn a bit about a universe. It kind of started as that, and created 2 new series based on, depending on what your level is. So people who might have a background in physics, some understanding of science, I've created a lecture series which goes into more math when it comes to astrophysics. And then a fun series where I actually just talked about the cup of coffee of the day and related to an astrophysics topic.
Astrophysics for dummies, basically. Well, that's a good segue because we actually got
astrophysics for the curious.
That works.
And definitely subscribe to her channel, please.
We actually have a actual PhD in astrophysics in here. One of my all-time favorite PhDs in astrophysics, Dr. John Kroon. Yeah.
Hey, how's it going?
I should have said Hugh Ross, but that would have I like you, but you're definitely my favorite. And by the way, I want to welcome his mom to the channel as well. Hi, Dr. Kroon's mom. Thank you for actually joining us today. But dude, how you been? It's been a while because you were on the Non Sequitur show a few times, and obviously know what happened there. But I've been missing you.
Yeah, me too, man. We're long overdue for this.
Absolutely.
I've been sleeping during the day and up all night collecting antique photons. With my astrophotography.
Aren't they all antique in some way?
But tell me about how time is spent in a photon. That's to make it antique.
Yeah, well, a photon would be created and arrive across the universe instantaneously if you go with the infinite Lorentz contraction interpretation. And so,
which would be cool, but it's not causality. So
right.
Well, there goes half my audience. They have no idea what you're talking about. No, I agree. So photons basically so what you're saying, to a photon, it appears to have 0 time. It travels.
But
to us, when we boost into its frame or look at what's happening in its frame, rather, yeah, it's going at the speed of light. So you get all these singularities from SR.
Nice. Real quick, we'll be reading super chats as they come up, so thank you for those. Helios 575, $2. From one Greek god to another. Hello, Athena.
Helios, what up?
Helios, my man. We had him on the other day, actually. He came on, we had a talk. So I guess we decided, we were kind of like figuring out what we want to talk about, even though you just had a video on GR, Athena, that primo. But we're going to talk about that one day, but I think we decided on pulsars and stuff, and neutron stars, and maybe black holes. I don't know. It's like there's so much to talk about just on those one thing. So I know Landon is digging neutron stars, and Dr. Kroon likes pulsars, so kind of like jump into that. So I'm going to turn it over to Dr. Kroon. He could talk about pulsars, and maybe the three of us can actually kind of just go from there. Because again, let's put it this way. One thing about this show on DEFCON 1 Science is I have to realize that I will always be the dumbest person in the room, and I'm happy with that. So I'm just going to kind of sit here and absorb the astrophysics as it reigns over us.
But Steve is being very modest because he actually is quite. I mean, he was batting away. I was throwing the astrophysics 101 questions, and he was,
I'm still the dumbest in the room, though. That's a statement of fact. I don't mind that. Okay, what you got first, Doctor?
Well, before I jump in, I wanted to ask if we didn't want to start with like a history of pulsars, because it sounded like before we got on air, Landon was kind of running with that, and that'd be a great intro.
Love
and
it.
We could get into the meaty stuff. So go for it, Landon.
Well, I mean, I guess one of the things you have to I was describing when I had the honor of going to the Ceti Observatory to help measure the distance between the Earth and the Sun. I was hosted by a gentleman named Franco Puccini, and Franco Puccini is considered the father of the neutron star. And one of the things he did as a theoretical astronomer was predicted properties of neutron star and what pulsars would be before we even knew about them. And of course, it was only a few months after his very startling paper that the first pulsar was discovered by a female astronomer, as everyone knows. But then then the advisor went and ripped off the result, and that's another tragic history. But there's happy history about pulsars, which I think makes them, they're some of the most fascinating objects in the universe, and they're nice in that they're not, black holes kind of shield themselves, where pulsars are exposed and naked in all their glory, which is why I like them better than black holes. But that's just a preference.
Quote from Landon. You heard it right here.
Pulsars are naked in their
They're
glory.
naked everywhere we like them. No, we don't judge. We like pulsars too.
Oh yeah.
Yeah, I mean, pulsars are awesome. I'll just jump in. The first time the first time I tried to explain it to someone was at a layover at LAX, out in Los Angeles, and I was in a Starbucks and decided I wanted to do a quick video on pulsars. So I used a Starbucks cup and stuck a straw out of one side, which is what a cup of coffee is like. Yeah. And I start rotating it in this video. And this person next to me is like, "What are you doing?" And I'm like, "It's a pulsar." And they're like, "What?" I was like, "Yeah, you see where the straw is? It's releasing. So it's releasing energy. It's releasing stuff that we're able to see. And every time it goes by, it's actually in a sequential pattern, which makes us see that it's actually a spinning, rapidly rotating neutron star."
Was it flinging out coffee through the straw?
I made sure to drink all the coffee, so it wasn't as accurate. But yeah, and I thought that was like really cool. And then they're like, "Oh, okay." And they're like, "So it's like a neutron star, but it pulses." And I'm like, "Exactly." So yeah, and then ever since that day, I started really liking pulsars versus like white dwarfs, or which are kind of just leftover cores of a giant star that died. But yeah, pulsars, man.
But the first there was proposal by Zwicky, actually proposed it in National Physical Society in 1933, I believe. And Zwicky is an interesting. He's an interesting character. He was not the most easiest to be around. He once described his. I think you can say this word. Just described his colleagues at Caltech as spherical assholes. and the explanation of why, because Caltech's full of fairly smart people. I mean, that's what Feynman was and so forth. I mean, so to say that is kind of a big thing. And his statement was, no matter which way you look at them, they're assholes. So why aren't they spherical?
So we're going to get John to kind of give us a rundown of what a pulsar neutron star is. Before we do that, I got a super chat real quick. Kawasa 5001. When they say a neutron star is practically a, quote, single neutron due to fusing together, is that literal, like one chunk of material? We're going to get into that, how a neutron star actually acts as a single quantum mechanical object. neutron, I think.
Yeah.
Hopefully, but so John, tell us what an actual neutron star and pulsar is. What's the difference, if any, and
Yeah.
what the hell are they?
Can I just before they're just finished because of the history?
Yeah,
Of
sure.
Pacini doing the property in '67, and of course Dressel and Bell at Cambridge detected an odd radio signal, pulsing radio signal. That his advisor said you're crazy, but it turned out to back the discovery of that. And of course, in '65, we also have the discovery of the basically a blinking spot was actually visibly discovered in the middle of the Prime Nebula pulsar. There's other ones there, but certainly Bell-Grinnell is probably the
So it
person
wasn't
that-
aliens then.
So yeah, it was called LGM-1. That was, I think, the first one, the Little Green Men 1, because their nature rarely produces signals that repeat so regularly, and also the period that is decaying away. We can measure those down to like the nanosecond level of accuracy, and it's a unique signature. The period and the P and the P dot form sort of a conjugate pair describing the pulsar's rotation. So yeah, we had the Little Green Men idea whenever we had first discovered them. But essentially, whenever you have a massive star like an O or a B star, which are the blue supergiants, whenever they run out of fuel to support their weight, the core can collapse and will produce a shock wave that rebounds and blows the star apart. And if the collapsing material is sufficiently massive, it will actually collapse into a black hole, which is one branch of the core collapse supernova endpoint. And then, of course, what we're talking about now is when it's not quite massive enough to do that, and the core collapse material results in a neutron star. And those are the most dense objects, other than black holes themselves. And so they're denser than white dwarfs. And they're very exotic objects. They have a lot of everything about them is just to the extreme. We'll talk about some of their properties in a minute. But the magnetic fields, and you have different classes of pulsars. You have like magnetars, and you have different modes by which they're powered, accretion mode. And then there's also the pulsar wind nebula, which is my specialty. I've written a few papers modeling the Crab Nebula gamma ray flares, and my analytical model describing how the pulsar actually powers not just the nebula at large, but an inner region closer in, about 0.1 parsecs from that pulsar, known as the termination shock, where you get a lot of high energy plasma physics occurring. And that's one of the things I love about pulsars in general, but in particular the Crab Nebula. They serve as laboratories for astrophysics. They produce environments that we just cannot, at least not very accurately or in the same conditions across the board, we cannot reproduce on Earth. And so nature has provided these high energy environments for us to make observations and test hypotheses and learn more about the way the universe works.
So people are talking about the Crab Nebula is in fact a fuzzy we've known about for a long time. In fact, Messier, the famous guy that had the Messier catalog, it was the crab discovering the Crab Nebula and thinking it was a comet because it's this fuzzy thing, and realizing that it wasn't moving, and that was inspired him to say, okay, that's not a comet, don't pay attention to it. And in fact, what Messier said to ignore is actually some of the most fascinating objects. And much later, we learned just how amazing that Crab Nebula is, because it's got one of those compact little rotating beepy thingies in the middle of it that you can actually see, right? With a wide-sized telescope, you can actually see blink as well.
So what causes a pulsar is a rotating neutron star, but why is it that some of them have that angular momentum left over, releasing energy, and some of them don't? Like, why is it some of them, like a neutron star, do all neutron stars rotate, or is it some of them rotate and some of them release energy beams from them, like a pulsar would?
Well, if the beam isn't pointed at Earth, you're not going to see the pulse. You wouldn't expect a neutron star to just have zero rotation. It's going to have even some rotation, but it's not going to have a beam that sweeps across Earth's line of sight.
That's mainly the big difference. Then a pulsar
That's-
is just a neutron star facing the beam toward us.
Mm-hmm.
where we can detect the beam. I mean, I think it's probably fair to say that all pulsars are neutron stars, but not all neutron stars are obvious pulsars.
But that's just because of orientation with respect to us, though.
Yeah, like that straw in the coffee cup.
The Starbucks coffee
The
analogy.
Starbucks cup. That's not a sponsor, but yeah.
But it could be.
Exactly.
Find our
So if
channel,
it's
Starbucks.
facing you- yeah, hey Starbucks.
Yeah.
Yeah, so if that beam's facing you, then you're able to actually see, oh, okay, there's a sequential pattern here. So we know that now this is a pulsar. And that was something really cool you said, John, about that the Crab Nebula is acting as a laboratory. I have to read up on some of your research. It sounds fascinating. And to look at it from that perspective, the first thing I thought about was how, yeah, it's not possible to have and harness as much high energy on Earth to be able to do these experiments. Meanwhile, we look out in nature and we see that actually going on. And, I think that that's something really valuable to talk to people about who wonder, why are we still researching these things out in space? It's so far away. How does it affect us here on Earth? And it's like, well, actually, if we're having this laboratory that just happened naturally, a natural occurrence in space, that's not only bringing us so many answers about space, but it's also bringing us probably answers for the future about harnessing energy. Like that's where my mind went immediately. I thought about Dyson spheres and all that cool stuff.
But
absolutely.
Nebula pulsar is pretty nearby. I mean, I'm trying to remember the distance to the Crab Nebula pulsar. It's about 6,500 light years.
6,500 parsecs, actually. No, light years. Now you messed me up. I'm gonna have to look.
I'm sorry. I think because it's about 2,000 parsecs, but I prefer light years to parsecs.
How many footsteps? No.
My wonderful roommate actually just gave me this.
Oh gosh, more energy.
So Starbucks sponsor for her. Go check out Athena's channel. Monster or Rockstar, whatever one contacts me first. I'm down for that sponsorship. Just do it.
But even a modest-sized telescope pointing up in Taurus will show you the Crab Nebula. But if you look at it through like the X-ray telescope, Trinosector X-ray telescope, or the Hubble, it shows amazing structure. And as I said, it's an amazing laboratory with really cool stuff going on.
I've taken a picture of it in the optical. You gotta. Yeah, here it is, 6,500 light years away. And another interesting thing about it is the only pulsar for which we know its exact age, because it was observed when it went supernova. The progenitor went supernova, and Chinese astronomers observed it and recorded it. It was visible during the day for a few weeks and at night for a few months. And it was in the year 1054.
Yeah, and what's amazing with the Crab Nebula is one of the very few, only one I've seen, I'm sure there might be others, but they've actually tracked it such you can actually see the expansion over a period of like 20, 30 years.
Yeah.
That's amazing.
And the Hubble's given us a really great, there's a nice movie of the recurring Hubble images that have come from that object. But it was also interesting that supernova event, the level of denial that went on in Europe at the time, right? The church said essentially that's the devil trying to do stuff, and don't look at it. And so there's an active pretending it didn't exist, even though there's this thing that's bright enough to be seen in the daytime. Of course, the Chinese didn't have all that.
They were looking at it more objectively.
Yeah.
Wow. It's like seeing the circle of life on a cosmological scale. It really is. We see like death, like birth, life, death, and then all over again. Because now, is the Crab Nebula one of the does it contain areas where it can also be like a stellar nursery, and this is where a lot of newborn stars are starting to form? I know a lot of nebulae can, but is the Crab Nebula a little bit too high radiation, too high energetic for newborn stars to form, or?
I think it definitely could, but it's still only about 1,000 years old, so you probably wouldn't see any protostars yet, but it probably will in the future, and that would be something we could look for, like a really, really early stage, like filamentary knots like starting to conglomerate. That would be really cool to look at. The Crab Nebula also is M1, the first object on the Messier catalog of 110 objects. And another factoid about this, not to turn the show into a Crab Nebula show, but
Talk about whatever you want.
the Crab Nebula has typically been such a stable emitter, a source almost across the entire spectrum, except for when you get a radio pulse. Like in the gamma rays in particular, you have a unit of, I think it's some sort of energy flux called the Crab. And it's because it is derived from a certain flux density from the Crab Nebula, and so it was so constant that this unit was coined. And instruments are typically calibrated when you launch a new space observatory, a gamma ray, for example, like the Fermi Gamma Ray Space Telescope. They would typically calibrate the instruments off the Crab Nebula, but in 2007 and again in 2011, and a total of 5 or 6 times since 2007, 5 of which were observed by Fermi, were flares. So we're like, this thing was supposed to be so constant and stable. We made a unit of measure off of it, and it underwent a series of very fast, very bright gamma ray flares that seemed to like to shatter our understanding of plasma physics and how synchrotron energy is produced on these luminosities below a certain threshold called the synchrotron burn-off limit. So what happens is when you have these relativistic electrons spiraling in the ambient magnetic fields, which are about 200 microgauss, and the magnetic in the nebula near the termination shock, if you're trying to go a certain speed, and you're relativistic, you're going to emit a gamma ray, and that photon will emit a back force on the electron. And the higher the energy of that gamma ray, which was produced by a given magnetic field and a relativistic Lorentz factor of that electron, the stronger the back force it's going to put, which tends to slow the electron down and limiting the energy of the gamma rays that an electron can produce. So there's this, it's called the synchrotron burn-off. It's a self-limiting process. And that was about, depending on if you do an anisotropic integral over a solid angle or not, you'll either get 140 MeV or 240 MeV, but order of magnitude about 100 or so mega electron volts for the gamma ray photon energy.
That's pretty substantial.
Yeah, it's pretty substantial, but here's what happened. Fermi observed it in April 2011. It's actually called the 2011 Crab Nebula super flare, like the super flare, because it was producing up to 3 GeV photons that were like an order of magnitude brighter than the highest upper limit that it emits during quiescence. And on a time scale that people could not explain. It happened, I mean, we had a variability down to 12 hours. And so so these things are essentially moving the speed of light. And so you could constrain the spatial scales involved in a plasma blob moving relativistically and being compressed through the termination shock.
Can you give an idea there real quick of how much exactly 2 giga-electron volts actually is? I mean, people probably don't even know how much energy that actually is.
Okay, so a photon that will give you a nice and fancy, good old-fashioned tan. It's probably, you get a suntan the old-fashioned way. It's about 1 EV. It's about 1 electron volt of that order. Mm-hmm. And then the X-rays you get at the dentist, which, by the way, I was just at the dentist a few weeks ago, and I always ask, like, how many KEVs are you guys using?
And they rarely can tell you.
And they rarely.
How is that? No, wait. To be a dental technician that works X-rays, don't you have to pass certain radiological tests?
I think because they'll go to CT scan and say, tell me about these photons.
Yeah, exactly. I want to know how much radiation I've been exposing to.
So mine was about 125 to 165 keV. So for the audience that's listening, that's 125,000 times the energy of the typical photon that gives you a tan. But gamma rays are in the GeV, and so that's billions of electron volts. So it's another, it was 1 billion times what that original UV photon's energy was, and so that's a lot. So we're talking about billions, and that's like, oh well, John, can you help the audience explain or understand and internalize and conceptualize 1 billion? It's like, well, we talk about it. We could say the word billion, but do we really
It's a
grasp
lot.
that?
Yeah. I mean,
Have you ever
depending on your
seen these pictures where it shows like a stack of dollar bills,
Yes.
and like here's 100, here's a million, and here's 100 million, and a billion? It's
Trillion,
just
quadrillion.
it's
Yeah, I
like
mean, depending on your
ridiculous.
photonic density, I mean, one photon at that value isn't going to do significant damage. But if you had a dental X-ray, that would be normally 100 some odd kilovolts, kilo electron volts, something like that, and you had it all in gamma ray energies in the gigavolts, you would probably die.
Oh
Die of
yeah.
cancer.
But you know,
None of
let's
those
say,
would do anything.
Yeah, you would have turned into the Hulk, by the way, right?
and you're saying in terms of the gravitational pulsar as you know as these significant sort of events, but understand that gravitational pulsar is an enormous mass that's spinning, and I believe in the spin rate around
33 millisecond period.
That's
about 30
incredible.
hertz or so, and the thing is that's got an enormous angular momentum. One of the first time, my first observational experiments I did was actually using the Fremont Peak telescope to measure the phase of the gravitational pulsar. And the nice thing is that it's a 0.8 meter telescope, and I put basically a rotating fan blade in front of the beam path, tune that to roughly 31 hertz, and scan across, and all of a sudden you see the star blinking in and out, right? For that because you're basically doing like the stagecoach effect. And so we used a 555 timer to get the blades going at a pretty good 31 hertz, and then measured the pulse from that pulsar. We had a WDB clock and basically synced the thing, and we're doing basically measurements of that, and it came back periodically every couple of months to observe the gravitational pulsar. It went behind the sun. When it came back out, we did the measurement, and we discovered that the Trav Nebula phase had shifted by a whopping 0.7 degrees. The phase of this pulsar shifted 0.7 degrees. People say, no, that can't happen. It's got too much angular momentum. But something happened there.
Where would the energy
at that
go?
time, but I say in 1988, we didn't have the gamma ray observatories. But if you just imagine, and you see a little bit of the shockwave from that event working out in the nebula, but a 0.7 degree shift must have been a massive starquake on that thing in order to get that. And I'm hoping it'll do it again, because that would be really cool to now have our X-ray and gamma ray scopes watch such a thing going on from there. But these signals, even though they're stable, they also have these quirks.
Now, John, are those internalized quake? I mean, when there's a star quake, when there's something, if you have a neutron star that's so dense, and all of a sudden you have a quake on the crust, what causes something like that? Because it's so compactified, it so massively has so much angular momentum that even a small amount of a micrometer quake is a huge amount of energy release. But what would actually internalize cause that?
Well, so you're asking a question that's like on the frontier of research right now. I mean, we it's not like something that's done deal right now, but I could speculate. I mean, as can anyone. You could speculate too, Steve.
I just make stuff up as I go along. You know that. I'm not the one with a PhD in astrophysics, though. I just ask the difficult questions.
So yeah, we think there is an internal structure, different all of which are extremely exotic states of matter, like quarks and then we have there's Bose-Einstein condensate, but like for quarks.
A quark soup.
And quark soup only, and they're like super rigid, and there's like extreme magnetic fields there that are like creating particle pairs out of the vacuum. And so you have just a lot of quantum physics and solid state physics and GR going on at the same time, and it's going to be something you don't want to try to solve over breakfast. You got to wait at least till dinner if you're going to tackle something like that.
Yeah, but we call it a neutron star, but in fact, it's not all neutron, right? The models, if they're reasonably correct, talk about the fact that the outer crust has a bunch of ions and electrons, right? That's part of getting the magnetic field. And then you have underneath that electrons, and neutrons and nuclei. Then you have your neutronium, your neutron, proton, weird Fermi stuff. And then maybe at the center you have some sort of quark, gluon. Those are bits and pieces of like protons and neutrons in the center, but we're not quite sure.
Yeah, we're not sure is the one of the most general answers to your question. Was that a super chat? You lost me too. My whole Skype crashed
Did we
like
have
a
a super
minute
chat
ago.
that I mixed? I don't think
Yeah.
so.
But in a typical model like the one that you use, there may be like 300 meters to 500 meters of ions and electrons.
Yeah.
And then about 1 or 2 kilometers of electrons, neutrons, nuclei. That's kind of normal stuff. And then you have about 9 kilometers of this neutron, proton, weird stuff. And maybe a couple of kilometers inside of even weirder quark gluon stuff.
So the reason being is, John, right? If you have a neutron star, it is so compactified that literally the electrons have been compressed to the nucleus and combined with the protons, forming a neutron.
The pressure is non-classical. It's all quantum mechanical Pauli exclusion principle based pressure at that point, and so that's how it's able to. I mean, the whole thing, it has the density of nuclear matter, and to a scientist that's like whoa. But to clarify to the audience, like, you take lead, even like the most dense thing you could imagine, it's still like mostly empty space. Like the atoms are spaced apart. Each atom, has this huge electron cloud, and where the electrons have like almost 1/2000th the mass of any single nucleon, and you have this teeny tiny. It's like 100,000 times smaller than the atom is where the nucleus is, and all that higher mass density area is what we call nuclear mass, like what 10 to the 12 or 10 to the 14 grams per cubic centimeter. And it'd be like taking every human being on the planet and compressing him to a sugar cube. I don't know.
I saw that in Star Trek, something similar.
Yeah,
they did that.
Sounds uncomfortable.
one of my favorite phrases about describing stuff is nuclear pasta.
Nuclear pasta.
Spaghetti.
I like that.
Yeah, they got
So
spaghettification for black holes and nuclear pasta for quark
That's actually
soup.
a technical term.
Yeah, I know.
yeah.
Pasta. Yeah, well, is there a technical term for like when you fall into a black hole that you may become spaghettified?
Spaghettified. Yeah.
I think that's considered to be technical now. Yeah,
That's an official thing. Yeah.
Now, correct me if I'm wrong though. If you have we're moving from neutron stars to black holes for a second, but to correct me if I'm wrong, we're going past what is the Tolman Oppenheimer Volkoff limit. I finally got it right, Landon.
Yay!
TOV.
Congratulations.
So once you get past the TOV limit for neutron stars and you go below the Schwarzschild radius, then you have a black hole. So if you have a supermassive black hole, John, why is it you don't have that spaghettification? Because why is it the gradient is so low that you wouldn't even know? If you pass the event horizon, you're like, this is really cool. Then you realize you're totally screwed, but you wouldn't get spaghettified, right?
Yeah, because so the spaghettification is entirely dependent on tidal forces acting on you, which is to say the difference in gravitational force felt from your head, assuming you're falling feet first, and your feet, which are closer and experiencing more of a gravitational pull. But think of it like this: when you have a smaller black hole. Look at radial vectors. I forget about GR for now. Just look at like radial vectors. They're very strongly convergent like this. But if you have a really large black hole, they almost appear parallel to you, and so these are related to the tidal forces you'd feel.
Well, let's leave
makes sense.
Black holes behind and focus on neutron stars because neutron stars don't get the respect that they should. Everyone goes off the black hole stuff.
Black holes are cool.
The thing,
they're cool.
They're really
man.
cool.
I mean, like this neutronium stuff we're talking about is super dense. 1 cubic centimeter, like a sugar cube size of this, is on the order of a trillion kilograms, or about 2 trillion pounds if we're sitting on Earth's surface. I mean, it is dense beyond.
It would fall straight through the Earth, blasting a hole through rock and stuff like it was air. It goes straight through our iron solid core, out the other side, and stop, and it would just oscillate back and forth until it stopped.
See, I thought that. I thought that too. But then let's do a mind thought experiment there, because I thought that too. But then I thought about this and was trying to look some stuff up on it. If you're falling through the Earth, right? If that thing's dropping through the Earth, but the Earth is also rotating at the same time, wouldn't it be more like falling through, but actually kind of making it?
Yeah, I left that part out.
Okay.
He was dropping it from the pole.
Yeah, I could drop it from the pole.
Okay.
Yeah.
Okay. Works for
And
me.
what
It
was
still
I gonna
screw up
say?
the Earth, though. The Earth would be like bad.
And it's 100,000, at least 100,000 Kelvin. Let's not forget that part.
Right. So,
Yeah,
so I
Just a
wonder how much.
minor detail.
So that would probably would that be hot enough to liquefy like the entire Earth, or that's pretty hot,
The entire Earth.
or at least a small. It would be a pretty good chunk of it.
So
Probably.
it's gonna be dense enough. I mean, because these things accrete almost at the Eddington limit, like active black holes do. So they probably start accreting matter onto it.
Oh.
I don't
Yeah.
think it would ever.
Yeah.
It wouldn't. It
But-
would start accreting our.
So if it did that, would it possibly become a black hole?
I'd have to think about
That
that.
would
It
be
would have
interesting.
to. I don't
No?
think it would.
No, I don't think of the density. But the other problem, of course, is that neutronium begins to decay. We did on the Ceti cluster. It's a computational cluster named after a Ceti. Again, there's a theme here. And we did a very detailed simulation of two neutron stars colliding. And it is weird, right? When those neutron stars get close to each other, the space gets really twisted to like more twisted than Twisted Sisters concert. And that one of the things that happens is that you don't have just two balls going around. The space starts warping, and the major blobs start coming towards each other. But the back end of the neutron star is kind of in a different sort of space-time than the front, right? Talk about stratification. Well, the neutron star, as it's beginning to collide with the other one, the back end starts going backwards, and it ends up looking like, have you ever seen like a crookneck squash in your supermarket? The bulb, that little dangly bit off the side. That's what the neutron star starts doing with this extruded tail, and the big blobs actually collide and do weird things. In our simulation, we had the two neutron stars light enough that they didn't form a black hole, because you get math gets really weird. But the tails snap off, and about a half a solar mass of neutronium gets recoiled, gets flung out violently to near relativistic speeds of this neutronium that's then sitting there, now not in the state where it's got the pressure, and so the neutrons then undergo decay, and you get protons, electrons, and antineutrinos. And in fact, one of the things our simulation predicts is that if we see a neutron star, look for the neutron decay, because you should see a flash that's really weird of all these neutrons beginning to have a half-life of it's about 1,000 seconds, something like that.
Something like that. Yeah.
All right, let me ask John real quick. I got a super chat.
So
I'll read in a
that
second,
cube going through the Earth would probably be undergoing neutron decay
at the same time. Yeah.
at the time, and that's going to be weird.
So let me ask John what he's talking about while it's doing that deformation, right? Obviously, anything that's going to deform a neutron star is going to release energy, right? Because losing angular momentum, you're having an effect on it. It's going to have a restored great space-time exceptionally amount. Does that actually set up gravity waves why it's doing that? Or is it actually when the neutron stars will finally merge and the bell rings, they have the ring of that bell, they call it.
Gravitational waves.
Gravitational waves, yeah, not gravity waves. Gravity waves we've known existed for a long time. They're in the sky. Clouds will, you can see gravity waves because of clouds, but gravitational waves, yeah. Will it produce gravitational waves as it's deforming, or only when they actually combine?
Yeah, well, it's the gravitational waves are being produced even before they've touched, because you have all this mass plowing through a very high density mass plowing through space-time. Space-time's kind of rigid, actually, it turns out, but these neutron stars have enough oomph to really cause some big waves. And so, and especially as the angular momentum changes, that's where you get some of the ringing shapes that we've observed from LIGO.
And they predicted those models. Let me I'll get a super chat. Let me ask Athena this one. This might be right up alley.
Okay, cool.
Again, love the mural. Everybody stare at that mural. That you have no idea what it took for her to put that up before we went on air. It was impressive. I really wish that was recorded. That was great. Great pre-show.
Neutron stars.
Peter asked for £5. Where is all the hydrogen and helium coming from now for the newer stars forming now, or when it will run out? So where's all this hydrogen and helium coming from, and is eventually going to just run out?
Wait, what is it? This is a generalized question about
where is all the hydrogen and helium
before star
coming
forms, or before star forms? Well, this ties in with what we were talking about before with having a nebula. So, or this has to do with neutron stars, right? We're not just okay. Just
no, it's a super chat, so I got to ask it.
Yeah.
It's the only way I make any money around here.
God, what changes the subject? Well, most of the time when you have a star that died, either like we were saying, either via supernova or a really massive star that just expelled its outer materials, a nebula would start to form, made up of dust and gas. That was the remnants of the star that died. And a lot of this has the necessary elements to form newborn stars, which is what we were saying earlier, is like a stellar nursery. So the Orion Nebula, which most of us could see with the unaided eye, even out here in New York City, I could see it. It's right underneath
Love it. My favorite one,
three
actually.
stars in the belt
Favorite
of the
nebula.
Orion constellation. So it's super cool. That's where I did most of my research when I was actually in college, and it was on protoplanetary disks. So this area of the sky, this nebula, there's so many compounds and so many different things that make up that dust cloud that form stars. And so the stars can start to form in areas where it's more dense, more lopsided, and stars can eventually start to form from this. And when newborn stars form, they start to spin really, really fast, rapidly rotating, can start to accrete anything else in that nebula around it. And so that's really where the majority of the hydrogen and helium would come from. And it's, like I was saying earlier, kind of the circle of life on a cosmological scale, where you have this remnant of a star that just died, and all of its stuff it left behind in space is now being used for new stars to form. So that's pretty cool. But then, maybe we'll have a white dwarf star hanging around somewhere, a neutron star hanging around somewhere. That was that core that is still left over from a massive star. But yeah.
But the first stars that formed would have been almost pure hydrogen helium with traces of lithium. One of the things that we're hoping to do with the Square Comet Array is to watch the first stars being born. Yeah. And try to answer the big question: which came first, the galaxy or the star, right?
So they wouldn't have the heavier. Obviously, the heavier elements have to be produced through nucleosynthesis, so that they wouldn't have anything higher than probably lithium, maybe beryllium, like that, right? Because
but the Big Bang, what was it, like 74% hydrogen, 23% helium, and a few percent lithium, and that's about it, right? And it wasn't until the first stars were born and died that we got interesting stuff. Yeah. Not that hydrogen, helium, and lithium aren't interesting, but
our star is like what, a third generation, I think.
Yeah.
Our star is like resurrection. It's been from other stars.
I mean, if how our solar system model forms reasonably correct, there were two supernovae, one 4.8 billion years ago and the second one 4.7 billion years ago, that contributed to the collapse. The first one, 4.8, caused a cloud to collapse, and you had this nodule, protocloud nodule, and then 100 million years later, second one seeded it. And that's why you see this bimodal distribution of elements on Earth, is because of those two nice stars that went bang. Otherwise, you wouldn't be here.
So let me ask it like a everyone dies scenario, because those are my favorite things. A neutron star. I love the everyone dies scenario. Neutron star, John. Let's say a neutron star just happens to be wandering around, because there probably are some rogue neutron stars, clearly, and probably a lot closer than we would like to imagine. But let's say there is a rogue neutron star or something along those lines that just happens to kind of come by our way. What would happen?
Well, first of all, it's going to perturb the tenuously binded comets and asteroids in the Oort cloud. In fact, some people think that the astronaut that killed the dinosaur. No,
the time traveling astronaut that went back in time and killed the dinosaurs.
The comet that killed the dinosaurs was because there was a star that passed by within the distance from Earth to Alpha Centauri and perturbed.
Is that some red giant that they said, or something like that, or red dwarf?
Although most likely the impactor that you could have peninsula was actually an asteroid, and we based it on the fact that we found nodules. Like near the South Pole, we found a centimeter-sized platinum iridium nodule that has a element mix that's dead on line with the KT boundary layer. So if it was a comet, it had lots of iridium and platinum in it.
All right. So if there's these perturbations and let's assume we may survive the bombardment from asteroids and the Oort cloud or anything. So we're going to be bombarded with crap as it gets closer to us. And let's say it actually. Now the problem that we have here is like neutron star is pretty decent size, right? It's a few kilometers across, right? So when it gets by the size about to Jupiter, we're going to be already kind of screwed, right?
Yeah, so these things, like I said, they're really small, and so they would be really hard to resolve spatially, even though they are about 100,000 degrees Kelvin. I don't know off the top of my head how difficult or easy it would be with all of the telescopes we have to see it. I imagine we would, especially if it's inside our solar system and near the gas giants. And things get interesting when you start talking about which kind of neutron star. If it's a magnetar with it's literally the largest, the most powerful magnetic fields in the universe, 10 trillion Gauss. No, Tesla, sorry. 10 trillion Tesla, so 10,000 times more than a Gauss is what a Tesla is. And these things are going to, and so if you look at the dipole distribution of magnetic fields, it ends up getting really, really strong all of a sudden when you're like really close. It's like, even for a magnetar, when you're far away from it, you're fine. Start having some problems, and then all of a sudden you just get like pretty much polarized.
It's not as gradient as gravity.
Yeah.
No, yeah, so it's like r to the 6th, 1 over r to the 6th for the dipole.
Yeah.
And so it's really sudden, and you'd be feeling that probably before after you felt gravitational tidal forces.
That'd be like stripping away our
radio telescopes would be going crazy, long before the neutron star.
Yeah, but I would think that like even normal matter, like the electrons would be stripped away and stuff. I mean, I just can imagine the effect it would have on us as humans, even at that distance with that much magnetic fields. I mean,
well, if it gets anywhere near any of the planet, like close enough, like for accretion, you're gonna tidally destroy the planet, and then you're gonna start accreting onto it, and then it's gonna become really bright neutron star. When they're accreting, they're gonna be generating X-rays,
lots of gamma rays, and
lots of gamma rays and stuff. And
but go ahead.
So and if it's already rotating significantly, then someone else is gonna see a new pulsar in their sky because then it's gonna activate all the radio signatures from the accretion, and then we're gonna be a pulsar in someone else's sky across the galaxy.
But what more exciting is what would happen if a pulsar met a regular star? They had a collision. Imagine Andromeda and the Milky Way are colliding, and some poor stars has the unfortunate thing of hitting the Crab Nebula pulsar.
Well, so I could draw inferences from binary systems, which a lot of the X-ray sources around, which are neutron stars or pulsars, are in. So when you have a large star orbiting a pulsar, if their orbits bring the larger star to within the Roche lobe, it's going to accrete from that larger star. And white dwarfs can do this too, and they could even go supernova when they hit that Chandrasekhar limit. But a neutron star would definitely, because it's so much more dense, and it's just it's almost a fundamentally different type of star than a regular main sequence star. It would defeat the star that crosses its path. It's going to start.
You get a series of what would be supernova class explosions. And if the star it met was big enough, you get enough material around the neutron star to crush it into a black hole, which would be weird stuff happen.
You'll get nova explosions, which are like, as the name implies, mini version of a supernova. They're just these huge thermonuclear explosions that happen when the matter slams into the surface of the neutron star, which is essentially a immovable surface and undergoes instantaneous and spontaneous nuclear runaway fusion, creating a huge bomb, essentially. That would probably, the radiation resulting from that would disrupt the star even further, as other parts of it haven't even learned that it's being eaten by a
That,
neutron.
that's my
Wow.
greatest thought experiment. And maybe we get Athena to come in too. I know she's just sitting there
Yeah,
so
I have
quietly.
so much to say
But
right
yeah,
now.
no, I
like,
know
wait a
I can
second.
tell. I'm watching. But maybe you can throw in here a second, like because when you're dealing with like two neutron stars, you're basically, like you said, you're dealing with immovable, inelastic objects. These things aren't forgiving. All right, I mean, so now you have really what happens when two immovable objects meet each other. Which is a classical thing in philosophy. Whatever happens, between an immovable object and an irresistible force. Now you have it, sort of thing. But
Yeah. Well, in fact, they are movable. They just don't like
Right.
to move, and they get really.
But think how much
cranky when you
people,
move.
the energy released of these things. We're able to see it billions of years later. We can detect it. But Athena's been dying to get in here. So
Oh, it's gonna be the most weird thing I'm gonna say. I don't know why, but I'm picturing the geekiest comic book right now of every. I just pictured. No, hear me out. I'm gonna draw this later, and I'm gonna share it with everyone who's watching this
Do it.
video. Of a neutron star, right? And its pulse is like a lightsaber from Star Wars, and it comes in contact with a main sequence star and just slashes it in. And then all of a sudden it causes this major warp in space-time, and also we like enter into a new dimension through like wormhole, and it just like interstellar happens. But that's the most off-topic thing, but that just made me think of it when you were saying how essentially the pulsar or the neutron star that we can't see the pulse of comes in contact with a massive star. Like what exactly would happen? And I just pictured like this crazy.
So imagine let's take something like a star like Betelgeuse meets a neutron star. The outer layers are going to give you nova, but by the time the neutron star gets to the core, you'll get a supernovae of just. But it'll be a weird supernovae because the star is blowing out, not crushing in. Most of it I think would be ejected. I'm guessing. What do you think?
Yeah.
I know the core reaches the neutron star, most of the outer layers would be blown out by sound waves. The sound waves, this thing would generate as matter is banging into each other and creating shock.
What about the pressure wave created? I mean, you have again an inelastic, basically an inelastic object. When something hits it, John, wouldn't it almost be like instantaneous? The other side feels it, like faster than the speed of light, or at the speed of light. You want to be faster, but it'd be like relativistic. The other side feels it simultaneously, almost.
Pretty close to
That's
it. Yeah, and this
that
is a pretty
boggles my mind.
small object.
Because that's in the collapse of a neutron star. What does in and forms a neutronium is a sound wave, a pressure wave, and what blows stuff out is another weird thing. A neutrino blast, because the neutrino blast that came from Betelgeuse's core hitting a neutron star, these neutrinos which go through everything, you'd have neutrino pressure of enormous pressure that would blow out
neutrinos who barely have any mass, if any.
Yeah,
you would have a lethal dose of neutrinos.
Steve, did you ever see this on XKCD? It said humans have the worst ability to intuit whenever you have a clash between really small numbers and really big numbers.
Oh, I haven't seen that.
But what would be more lethal? A 50 mega, like the SAR bomb, the thermonuclear bomb, held up against your pupil, like all the way pressed up against your eye, or a supernova from 1 astronomical unit. And it would be this just the neutrinos from the supernova at that distance would be more lethal than the nuclear bomb.
You can't wrap your head around that.
Moreover, that supernova would be over 1 trillion times brighter than the 50 megaton bomb.
But you can't. Your eye. But John's right. As humans, we have our limitations, and very small and very large numbers and things like that. We have a very difficult time. Our brains aren't wired for that. It's just we're not wired to handle very large and very small things.
We only need to know if there's a tiger that's going to eat us.
Yeah, evolution doesn't give a shit about 10 to the negative, 30 microns or something,
But that's what makes simulating neutron stars so difficult, because if you want to do accurate stuff, you need to worry about neutrino pressure.
Yeah. And can I do this on Universe Sandbox?
Oh, do you have Universe Sandbox?
Oh, yeah.
I haven't played that in so long. I haven't, but I remember doing these ridiculous numbers and simulations. What is like the max limit you can do on Universe Sandbox?
It looks so cool. I haven't tried it. John, do you have Universe Sandbox?
No, I'm about to though.
It is like
Wait, you've never
you
had
could
it?
do anything. I've looked into it, right? But it looks like something like you could literally make any universe you want. You can set the parameters, the physics. You can do the orbitals. It's high end stuff,
Whoa,
like
I'm
NASA
getting
level.
that.
Yeah.
Hold
you
on.
can change
Have to do
constants
that.
and see what happens.
Yeah.
But Athena, I hope when you do your drawings, you have these little neutrinos that no one really pays attention to, all of a sudden gang up en masse and pushing
They're
those
fighting
outer
each other.
layers.
Little neutrinos going. So wait.
I'll make
So
that
wait.
sound effect too.
Landed. So even the Universal Sandbox, if I wanted to change like the fine structure constant, like instead of be like 1 over 137, I could make it like 137.1 and see what happens, and
Ooh.
that would be
Yeah,
like awesome. And see how it affects like the
I'm
Coulomb bar
getting it.
barrier and other natural units. I would see that's my jam right there. I would love to do that. Play with that.
Yeah,
How did
'cause
I not
next,
know?
next time one of
Next
these
time we'll just play.
Yeah, we have a let's play. Yes, I'm down
Yeah.
for that.
these
That'll go to
younger
So I
search.
don't have to tape this up behind me next time.
That'll be
so
your
that-
background as the universe
Whoa.
simulator. Yeah.
When next time one of these young Earth people
Found
try
the
to
John.
say that the speed of light can be slow, change C and see what happens, right?
I would
Yeah.
love
All
that.
atoms just go boing.
Yeah.
Right?
Well,
It's-
if you change the
man.
fine structure constant, obviously C is going to change, and that's going to be a problem. Also,
Yeah.
the Coulomb barrier is going to be affected, so you're going to have very different quantum mechanical effects even inside the the atom itself and the relationship to the electron and the protons and neutrons in the core. So yeah, bad juju's happen when you start changing these numbers. You know.
Now, by the way, back to neutron stars. There's some terms that are important to remember when we talk about the nuclear pasta, because there's a thing called a gnocchi phase.
Love
I'm
gnocchi.
serious.
What? There's a gnocchi phase? That's my
And
I
favorite.
thought that was a type of
Spaghetti
food. Wasn't that a type of dessert?
And a lasagna
No,
phase.
it's a pasta. It's
It's
And
pasta.
a
Oh, it's pasta.
spaghetti phase. There's also a Swiss phase, but yes, there's a bunch of phases of nuclear pasta that you bring
What's a
in.
tortellini?
And of course, these are real. I mean, look up gnocchi phase. Look up spaghetti
All right.
phase.
Yeah, I've actually
Lasagna.
heard something like that with the different types of cannellini and things they've done for the nuclear pasta.
And this is all weird stuff inside the neutron star. They're just weird.
Yeah. This is why people
I'm
go,
really
those
surprised
scientists
I
are
didn't-
weird. What's that, Athena?
Yeah, I mean, scientists definitely are weird. I said, I'm surprised I didn't hear about this. I'm the one who recommended neutron stars.
Yeah, no, I've heard I've heard the pasta models and I think they actually did have tortellini. I don't remember. I know they had some other types of structures they call it in the nuclear soup. But you know what? Maybe the Church of the Flying Spaghetti Monsters got something going on, right? Maybe they know something we don't know. Pastafarians, rock on.
Wow.
John's looking at this program. He's just dying. He's like, I must have.
Yeah,
I
I
mean-
gotta play with this real quick. Give me a
We
couple
go into
hours.
this
yeah, let us
Yeah.
know.
Bye, Landon.
interesting
Screen
for
share?
what happens. But just to say there's a bunch of neutrons is belittling the complexity of neutron stars.
Oh yeah. By the way,
Sure.
John, did it? By the way, I have so many streams, so please forgive me. But I'm pretty sure wasn't it you I had on for Kerbal Space Program?
Yeah, that was
Yeah,
me.
yeah. So we did I don't know, Athena. Have you played Kerbal Space Program?
I haven't. and I've
It's
been
so
told
good.
that
Are you kidding me?
I know.
It's so
I have
good.
to.
It's fun. It's
I'm
nothing
ready
like
to
it's nothing
check
like
out. I'm
Universe
ready to forget.
Sandbox, but it's
We landed on the moon. I think it only took like 3 tries or something.
no. Well, it took like 3 hours, but I'm a scum saver, so
I
I'm a
don't
scummer.
do fly around the Earth or go to the moon. I go to some of the outer planets because that's
Outer planet.
I haven't figured out how to do the delta because you need a certain amount of fuel in order to do your delta V in order to get your thrust perfect, so you can actually go to those other planets, and you have to actually do those mathematically or use a chart or something. And
So cool.
yeah, they really do it
So
up. I mean, it's
nerdy.
not, you cannot get to those other things if you don't understand the science. It's just not going to happen.
The New Horizons, they didn't have a joystick doing
Yeah.
this stuff.
No,
They-
this
they-
was
they
all
thought about it.
calculated with actual delta V's that you needed. So you had to design your rocket to go, okay, I need this much fuel to do this burn for this amount of time. And yeah, it's pretty intricate, I got to admit. For it's simple, gooey, but the physics is amazing. Yeah.
Wow.
Oh yeah.
Are you ever able to stop stop time at all for any instance? Because I always wondered about that. You know, like I know last time I was on, we spoke a little bit about the no boundary proposal, and I'm not gonna get into that. But that always
I
makes
did
me
a
wonder
whole
about things like
presentation on
this.
it. Yes.
You know, yes, yeah.
Because
yeah,
I got to talk to Dr. Krauss on that. Literally, Dr. Krauss.
Okay, nice. But I always wondered that, you know, like earlier too, we were talking about like what happens with you know, like I forgot what it was you guys mentioned before, but you were saying about how, you know, with time you'd have to move at least at the speed of light, and I'm like, but what if the speed of light isn't as fast as we think it is, because we cannot understand time in a different way. And so I always kind of like wondered what other people thought about that when it came to
I'm gonna
time.
let John go on this one because you're gonna hate my answer.
Of course, if you're not a photon or a particle with zero rest mass, you have no business going the speed of light.
Yeah, don't do
vacuum.
it.
Well, what about
Don't go at the
tachyons?
speed of light.
Yeah, tachyons don't care. But John, go ahead and take that one. Then I'm gonna give you my really philosophical answer that you're gonna hate because scientists and philosophers don't mix. So,
well, it was only once I saw a scaled down model of our solar system that it put the speed of light into perspective. Yeah, it's really fast for us and all that. But check this out: if the Earth were the size of a marble, and the sun on that scale, the sun is like it's like one of those inflatable spheres that are like 10 meters in diameter or something like that.
Mm-hmm.
And don't quote me on the exact number. Anyway, so if you were to go into like the desert where they did this experiment, Stephen Hawking did it, and you have the sun there, and then the Earth is something like a half a kilometer away. And if you were to go from that model sun to the model Earth at the speed of light, it's a walking pace. You're just a 3 mile an hour, you're walking. And now that's just the solar system. You're walking. 8.5 minutes later, you get to the Earth, hours to get out to the outer solar system. So it's fast, but the question is the universe just too big and the speed of light really is fast, like in objective absolute terms, or is the speed of light it's still fast compared to us, but not fast?
I think it's the latter. I think that it's fast, but I think it is a hard limit. And I'll give you the philosophical, too long didn't read version. When it went to Athena's question, then I'll read the super chat. Time is looked at two different ways in philosophy. But basically, there's obviously theory A and theory B, but there's what's called reductionism versus Platonic theory with respect to time. So reductionism or Platonism with respect to time. And what they are, the difference is one actually holds that time is an actual construct that actually exists with an actual property. And so if all movement stopped, if there was absolutely no movement in the universe at all, no change, time would still exist. The other way of looking at it is if all movement stopped, there was no difference between anything in the universe. Absolutely nothing. No Brownian motion, no quantum mechanical motion, nothing. Time would stop because time in that case is more evolutionary. Time would be something that doesn't have an actual existence. It only seems to exist because we're noticing some kind of change. I subscribe to the latter, but there's reasons why some philosophers subscribe to the first one. And scientists too. But go ahead, Landon. Do you want to touch that?
I mean, Steve, I think of time as measurement of causality.
Right, but
and if there's no cause and no effect, you can't measure it.
To a reductionist, to a Platonist, there's no.
Time just becomes a theoretical concept at that point if you have no cause and effect.
Yeah, and I think that makes a lot more sense to me. Helios 575, $20 super chat. Thank you, Helios.
Excellent.
Okay, let me see if I can read this. Okay. We have stabilized positronium particles in extremely advanced labs, but do you think that unique particles that are created when neutron stars collide, what do you think would happen if a pulsar got infected by strange matter? Okay, I'm going to turn this over to John real quick, but a strangelets...
Wait, strange matter?
Yeah, like strangelets.
Oh, like strange
so strangelets are interesting because I don't know if you guys remember before you guys' time, there used to be a show called Odyssey 5. And great show. It was with Peter Weller. And it was based upon the existence of strangelets, and the strangelets have a weird property. If we have strange matter and strangelets exist, if they're polarized one way, if they spin one way, we're screwed. It would basically have accretion to it, and all strangelets would actually kind of have this weird attraction, and everything would become strangelets. And this was what the show was based upon. But if they spin the other way, we're fine. And I don't know the physics as to why, but he's asking what would happen if a pulsar had this strange matter, strangelet. Kind of infected, I guess.
So it's just quantum chromodynamics at that point, It's like look inside the Atlas detector, and you'll have the particle zoo. You have all these particles. Some of them decay in 10 to the minus 23 seconds. You have a lot of neutrinos and anti-muon neutrinos running around, and it's just it'll be a really hot particle physicist plasma QCD soup.
It'd be bizarre, wouldn't it?
It would be bizarre if you had a good time resolution and energy and spatial resolution on it.
Just be sure you have your detectors around it because it'll be a cool.
Yeah. Do you think?
Right? Don't waste.
and this is to anybody, do you think that, we have a pretty decent of understanding of physics and not us generally, but I'm saying that as a human race, we have a decent understanding, at least predictability of things of classical mechanics and GR and special relativity. And even so, quantum electrodynamics and quantum chromodynamics, we have an understanding of these things. But do you think there's a type of science out there and type of physics that is so far removed from any of that, we haven't even begun to actually tap into it?
I would hope so.
I would hope so.
Totally.
I would.
Totally.
I would think so.
Wouldn't that be
would not
awesome?
Start with saying we understand. That's the first thing, Steve. Don't assume we understand physics. We have models.
Better than we did 200 years ago. Yeah. So what would you think something like be like if you had to hypothesize on that? What would that type of physics be like? That would be so novel and so unique, kind of like the way relativity was to a Newtonian physicist. What would you think we would be involved in some kind of advanced quantum electrodynamics that would be so beyond what we have now? I love these mind things, by the way.
Oh, I feel like it'd be something like an episode on a Black Mirror where your subconscious downloads onto a chip. And so there's like this whole other world that you access in the non-physical world. And that would be almost, in a way, quantum mechanics, because it'd be like entering another dimension without actually entering it, but it's more like accessing it without previously knowing that it was there.
All right,
I almost feel like that would be
possible. All right, let's dive into that. So, John, do you think there's possible other? And I don't. It's not like possible world semantics or even multiverse. But do you think there might be dimensions out there that are congruent to ours that we just have not tapped into, but we feel maybe the influence of them?
I'm of the mind where I would need some sort of tangible evidence, even if it's not corroborated, before I would be comfortable discussing that in any real way. I would think it's cool. I would think the universe has shown to always be more okay, what was that quote? Einstein said the universe isn't more what do you call it? More interesting than you could understand. It's more interesting than you're capable of imagining, And so that's not really a scientific reasoning, but it definitely is just sort of a gut feeling that there's probably cosmic strings. You remember those?
Yes, of course.
One-dimensional, cosmic strings, axions, a lot of exotic physics that would typically be relegated to science fiction. At least some of them got it.
Quantum filaments.
But I think if maybe, Steve, the way to talk about it is what will 200 years from now, assuming we have similar progress in science, what will they be laughing about?
Oh, we'll be like cavemen at one time.
And I think,
yeah,
I think
they'll be watching Athena's videos going, God, this chick didn't know anything. Yeah. God, caveman times. Yeah.
That those people will be laughing at as they say, what idiots, right?
Right.
They kept saying the word string theory when they should have said string hypothesis and string model.
Well, I yes and no.
Is not to the level of theory, and they'll laugh at our attempts to try and get quantum mechanics and general relativity.
I get that.
To measure, but I want to know what they would say.
I'm okay with calling it a theory, and the reason being is that I know we disagree on this vehemently. And the reason I'm okay with calling it theory is I think it's based upon mathematics, and in mathematics you have theories. It's not a scientific theory, though.
But it's not testable, right?
Well, at least not now. Yes.
Not science.
Give me a prediction.
No,
Don't
I get you on that.
Fit reality. Give me a prediction, and let's test that.
Sure. I agree with you there.
So no.
Well, multiverse is the same way. How do we test for a level 2, 3, 4 multiverse? Now, one, I think that everybody agrees level 1 multiverse exists. I think that's kind of obvious with the Hubble's volume. But how do you test for a level 4 multiverse? I couldn't even imagine how that's even testable. You couldn't do it. So I don't mind hypotheses out there as long as, like you said, people recognize they're not scientific theories. They haven't been confirmed, haven't been substantiated. Some of them haven't even been designed. How would you even test them? Like, how would you test quantum suicide? Yeah, you couldn't really do it, right? And if you tried... and guess what? You failed. You're kind of SOL, right?
Well, then there you go.
but there's nothing wrong with a string model, and the work they're doing on it is very important.
Precursors to something else.
It just hasn't hit the theory level yet.
Yeah. Well, I remember back when, back in high school, I wanted to be an astrophysicist. Then I found out something that kind of bothered me. I found out that the math is really hard. Yeah, and so I changed my mind and went into nuclear technologies and physics, but whatever, it's still really hard. But I went to a college level course. We had a community college next to us, and this was probably like my senior year or somewhere around there. and it was on closed timeline theories. And I don't remember the person who was giving it, but back then they were talking about the same things we're talking about now. These filaments and closed timeline theories, and you know how the universe operates. And we haven't. It's been, you know what? I don't know, 30 years. We still haven't figured it out. They're still the same open questions. Yeah. By the way, did John get really small all of a sudden?
Yeah.
It's a law of perspective.
Yeah, law of perspective. It's a real thing.
My head actually shrank. I'm actually smaller.
That's cool.
So weird. I want this feature. How do I do that?
Just back up.
You just turn your blur on and back up. There we go. Look at that.
But I don't have the blur on.
She's so diminutive. Yeah.
Yeah, but if you blur, then you'd be so. I've been looking at their background and saying you've got a cool nebula there, and you got this other planet that's pretty close.
And a staircase. There's a random staircase, right?
So I'm worried about the state of the planet you're on, given. Oh, well, there's a staircase.
Okay.
But that other planet, isn't that going to be?
No, Captain Marvel. Would not she make a great Captain Marvel?
Oh yeah.
She looks like Brie. What is it, Brie? She looks like.
Is that a star?
There you go.
Or those are two planets.
I think it would be. I think it's supposed to be a planet, and it's you know, probably it's satellite, so a moon up there. Wait, let me make sure there's nothing weird on the wall. Okay, just tape.
But how do we know right now that you're not actually like a Brie Walker who is Captain Marvel, and you're not actually in space right now? Because you could pull that off pretty easily.
What are you talking about? I am in space.
Yeah.
Like, I'm actually in space right now.
You missed your calling. You could have gone and worked for Marvel.
We're not in space. What?
I could change my background too. You know.
No, that's supposed to be. It's supposed to be a. I think another planet. Definitely don't think it's a star. Another planet, and then it's or it could be I don't know what it could be, honestly. Definitely not a star. And I think I got off Amazon.
I have this one.
I wanted the one that wasn't accurate. What? Your background
this is the one for I have when Landon comes on. My math background.
And,
I know it's really hard to see
because I look at some of the stuff. This the question is,
don't look at those. They're not right. They have errors.
Was it done by a mathematician? That's the question you ask.
Definitely not a math.
Yeah, if you have OCD, don't look at that math background because there's some issues with it. It'll drive you nuts.
Yeah. But I love the geophotography of those spires there. I mean, it suggests that you've got a pretty good. I guess you have water there, so you've got salting going on there.
Yeah, there's like a nice lake down here, and
methane.
Those are probably then cores of old volcanoes, right?
Yeah, that's probably methane lakes, right? That's probably like a couple hundred degrees below zero on that rocky Titan-like planet.
Yeah, I mean, I always wanted to live on a planet that had two sunsets, so I like to pretend that is a star, even though it looks more like a planet because it looks like very rocky. It looks like it has craters on it. And so, or it could be a moon,
brown dwarf.
Maybe it's a brown dwarf, and then with another little, with its
a planet around it.
That's actually a great question. I know we're going all over the place, but John, do you think that?
So then these are both two planets orbiting that brown dwarf.
Do you guys think that Planet 9 could be a brown dwarf or a micro black hole?
Planet 9 is Pluto. Planet X probably.
Okay, fine, whatever. You guys change it all the time.
Man.
Yeah, you guys can't even get your shit together on that. So whatever.
I would have my
Planet
money
X,
on just a regular planet and not a brown dwarf or a black hole. Certainly not a black hole.
You don't think so?
I don't think it's a black hole.
That'd be so cool.
I'm very critical of the type of science that those folks are propagating, right? For example, what they do is they cherry pick and say, give us more money to search for something. When in fact we know that there are stars that touch even the Oort cloud, and you're telling me that some super planet out there is causing a slight changes in rotation. We have stars coming near the Oort ring, and they say but why? Because they want to get money from other people to go to them for their silly search. And Mr. Pluto Killer and Mr. Planet 9 can go and go away. They're never going to get
Pluto Killer,
right? The silly folks of that, because there are very reasonable orbital mechanics explanations for this that don't fit their narrative. So
Landon, I have a question for you. You think Pluto's a planet then, right? So is that what you're?
Of course, it's called a dwarf planet.
Question then. Okay, great. So then, do you consider the other 389 dwarf planets that are beyond Pluto to actually be planets as well, or are they just?
Yeah, because we have about 115, at least
No, that's how
115
many planets
dwarf
are actually in our
planets
solar system.
we have 115 planets in our thing according to geophysical definition, right?
Planetary
So the
geology.
paper put out by Alan Stern, geophysical definition of planets, and using that definition, there's at least 115 planets in our solar system alone.
Right.
Yeah.
Yeah. But I mean,
Okay, that's what I was wondering, because some people don't. They say no. Well, we don't really consider those dwarf planets.
But I mean, I remember when
solar
Tyson
system,
was
which they
sitting there
are.
saying, yeah, but there's too many planets. I say, so we should knock off the elements beyond uranium because there's too many elements for people to.
yeah, no,
Exactly.
And we should take hydrogen because that's too small
look,
to be an element.
but what happens is people don't like to bloat their ontology, right? And I understand that. But I have no problem with dwarf planets being called planets. Pluto to me will always be a planet because I grew up that way, and you're not going to change my,
No.
you're not going to rewrite my history of my childhood, right? My childhood was not a lie, damn it. Pluto is a planet, and so if they want to call Sedna and the other objects out there in the Oort cloud and Kuiper belt, whatever, they're pretty decent sized objects. I'm fine with that. Call them planets. Whatever, it doesn't bother me at all.
By the way, our moon is a dwarf planet. And
Yeah.
in fact, when
I'm okay with that too.
IAU had 300 people come with this stupid definition in violation of their procedures, when in 2010 we came back and we said we got to delist Earth because it hasn't cleared its orbit because it's got this big hunking thing in there, and we got to delist Jupiter.
I remember those conditions they came up with. Yeah.
Or Trojans, and same with Neptune, and so they said, okay, fix it. But that's the thing. When people say, is Pluto a planet? It's called a dwarf planet, and there's nothing wrong with being a dwarf.
Yeah.
Dwarf
Now,
stars are stars.
I prefer goblins because
our galaxies.
A goblin planet.
I prefer hobbits.
Hobbits.
we got okay. So he's Hobbit. I'm Goblin because the Cheshire is my other co-host. Caffeine Corner's
I
Goblin.
like gnome. I'm a gnome.
You're a gnome.
There you
Okay.
Like a
And
garden
it really
gnome.
is funny because you started to say, well, aren't dwarf stars stars and dwarf galaxies galaxies? So why aren't dwarf planets planets?
Well, the word planet, this is what I tell people on the comments section, which I advise you guys to avoid at all costs. Never read the comments because you're going to facepalm like that. So, but I was on this one comment thread just on an innocent one, and I was like, look, guys, just relax. The word planet appears in the following: dwarf planet. What's the problem?
Dwarf planet is a subset of planet.
Yeah.
I don't know why that's such a big deal.
I know, right?
Subset
I'm
of a
all on
set.
the same page with this.
Yes, I think so.
Some people are really like, no, like it is not a planet.
People will
This
argue
is a
about
planet.
anything.
And then I'm like,
And given what we know about distribution of planets, most planets are dwarf planets. Pluto is probably the norm, and Earth is kind of the bigger rocky junky thing.
Well, we definitely think Earth is atypical because we've found thousands and thousands of planets, and there's not one yet that's really Earth-like, so to speak. They're either too hot or too.
There's some that are close.
Yes, yeah, they're still too large or too hot. They're still not exactly something we would typically be able to go to. And by the way, we'll have to do an episode one day on, because I would love to do this. What would happen? I need a biologist probably, but what would happen if humans actually did go to another planet? To me, I don't think it's possible. Not because of physical limitations. It is because if we went to another planet that had life, that was habitable, we would be so compromised with an immune system that would not be able to handle anything of an alien thing. It'd be like Martians coming down in War of the Worlds. I don't see how biologically we could actually colonize a habitable planet that already has life on it. That's something I would love to talk about because I just don't think that would be possible because our immune system would be so different, fundamentally different. Because we go to we go to a different part of the Earth sometimes, and we could get immunocompromised.
Well, Steve,
and I get
let me just tell you this much though. At least for bacteria, I'm with you, and like fungi and whatever else is on the planet. But for viruses, they're very targeted towards certain species. Like that's the same reason why
fair enough.
An oak tree can't get a cold, even though they're here with. I've sneezed on a tree, felt bad. But I did it, and it didn't seem.
Did it catch it? Yeah. No. Okay, you're right. Bacteria and fungi more than anything else. But sure.
But
there have been viruses that went from species
Actually,
to species.
3 times. Once when I was 11, once when I was 19, and once 2 months ago.
So you repeated the experiment several times.
It was an accident each time. It's just
So we're gonna ask the entire audience, go outside, sneeze on a tree, and let us know if that's
does it get cold?
Yeah, just get sick.
Wow. What
things
is
we
it
talk
like to
about.
get sick in space though? What like is it like what if someone goes up there and they're like coming down with a cold and then you get it from them? That must suck.
Yeah, well, and the other thing is,
Yeah.
Colds, it's really
we
bad.
know being in space for a long period of times does have effects, not just physically, not just on the bones and muscle, but on the DNA level.
Yeah, totes.
So I mean,
Vomiting,
Mutations, yeah. You said
vomiting
something
in your spacesuit can be fatal.
well, yeah, that would be
yeah,
bad.
the emission, yeah, what it releases and
Mm.
gross. That shouldn't even be in the body.
Don't puke when you're out on the spacewalk.
Wise advice.
Okay.
Let's see if we got some questions from
Yeah.
live chat. We've been going at it for a while here. By the way, it doesn't have to be super chat. Just it's ask your questions. I mean, you've got 3 of the smartest people I know in here. By all means, ask what you want.
About the backdrop.
I gotta get me one of those. For
Yeah,
next
but I mean, I
time.
always go
Okay,
at this-
okay, Athena, do you want to expose what you did?
No.
Okay.
What are you talking about? I'm in space.
She's in space.
All right,
There's-
And
there's
I want people to know how much effort this was a project for you today. It really
Right,
was. It
let's
was
do it.
fascinating to watch.
Oh, yeah.
So
We're-
it started with nothing back here, and then I had no hammer for my nails, so I decided to just get some tape, and I put tape up.
Her life is a
And-
lie. You see this?
See, this
What
is,
are
this
you
is,
talking about?
but Athena, this would be like an exam I would give for astronomy students. I would put that up on the wall, and I
That's a
said,
great
"Tell
idea.
me everything you can about
Ooh.
this
Accurate.
world."
That is good, actually.
That's actually a really great thing. Tell me everything that's inaccurate about this. There's
Oh, and,
so
tell-
many things
tell-
that could be
and,
inaccurate.
and make observations about this and what's going on, and tell me about what you're seeing, right? And speculate, right? Would be the thing.
Wow, that's such a great thing. I think, yeah.
All
We
right,
should.
You wouldn't see the nebula.
all right, so let's get some questions
Yeah,
in here.
this is the-
So one person asked, they want to know how dangerous Apophis, the asteroid. I don't remember. It's supposed to come around. They're supposed to come around again.
So in April
Yeah.
2019, it was observed to go through or not go through a keyhole size part of space. If it went through the keyhole, then it would hit us 10 years later, also on Friday the 13th in 2029. And that was earlier this year, and it didn't go through the keyhole. So now they've constrained the orbit more accurately, and we know it won't hit us on its in 2029.
And if it did, what would be the result, you think?
It's depends on where it hit. It'd be like a local disaster, city killer. If it hit the Pacific Ocean, it'd be a multi-city. You'd have tsunamis just pretty much wiping out coastlines, because so you have like this 3-mile wide hole in the ocean, and waters don't like to have just like a giant hole in them, and so they would go boom and clap together, creating another. Do that about 30 times with a decrease.
One of the things that would come out from forming that hole is you get a supersonic ejection of water, and that would slow down the subsonic, but it would be skimming over the water and boiling as
Wow, that would be.
You'd hit the coastline with the scalding.
See, that's what I'm saying.
wall of water.
2 places you don't want to live next to
It's
is the ocean and a caldera. Don't.
It's
2
much
places you don't wanna
better
live next
maybe
to.
if it hit land than ocean in some ways.
Yeah. That brings into question, though, if we would have like a brief like nuclear winter, though, putting so much dust in the atmosphere.
Yeah.
That might cause other problems, but I don't know which one I would prefer. I'm not by the coast along the Pacific Ocean, so I would take the Pacific Ocean.
Yeah, I'm a few hours away too, like 2 hours. I probably could reach the ocean if I had to in an hour. Well, direct line of sight, but I'd probably be screwed if that would ever happen, if that thing did hit water.
Yeah.
But where are you guys at? Landon, and I think you guys are on the East Coast.
They can't reveal. They can't tell because of top
What?
secret CIA
I'm in the
reasons.
Silicon Valley, so I'm West Coast.
She's just past some kind of like Andromeda, something or other, where she's at.
Yeah, because I would tell my students, speculate where this is located and tell me why.
Yeah, that's a cool
Tell me
exercise.
where Athena is located right now, given the background.
I would say the one of the arms of Andromeda.
And tell me why, right? That would be
Just because I make shit up as I go along.
Hopefully,
By the way,
no
I think
office is gonna attack.
Makes
Hopefully, no whatever it would impact.
We got this was it's funny. We actually got an astrophysicist here, but this is directed to Athena.
Oh gosh.
So Athena said they asked Canadian sister asked, is there proof of white holes?
Oh gosh, I'm gonna pass.
There
that
you go.
question.
Smart answer. John, take it away.
So
As
no,
far as
there.
proof goes, I don't think there was any evidence collected for that. But John, I'll let you do that.
So yeah, I would agree. If for what is hypothesized or even posited, it's not even really based on physics evidence. It's more of a posit. But they say that a black hole is connected through hyperspace to a white hole, and it's just like one sucks everything in and the other just spits it out, and not necessarily in a causal way. But if that were true, we would see billions and billions of white holes.
Unless they're in
'cause
another
there's
universe.
a lot of. Oh, come on!
Well, I mean,
Wait,
because
wait,
basically you've got an event horizon where you can't reach. That's to say, as
Well-
opposed to being sucked into it.
Well, okay, and I agree, and I don't think they exist either. But there is some theories out there that would relate two black holes in the same universe being causally related past the point of the singularity through quantum tunneling, right? If you have two black holes that have been superpositioned at the primordial time and they've gone apart from each other, theoretically through EPR, you could actually have a wormhole between them. Although I don't know what good that would do you. You're still like bounded by the event horizon. But isn't there some theories like that? That they're quantum mechanically related in superposition, and a photon could go through some kind of EPR bridge, but the problem is that it actually causes denigration of the bridge and collapsing of it. So you really doesn't do anybody any good. You're not going to be able to get to any part of the universe through some kind of wormhole, and even information is going to be very difficult to pass through.
Unless you have negative energy and you could hold the mouths open.
Okay.
Yeah, but let's. I mean,
That'd be
let's
cool if negative
careful
energy
here.
existed.
The mathematics doesn't rule out a white hole.
Right.
But remember, the universe does not care what your models are, right?
Math
The
doesn't
universe
represent
ask
reality.
Your permission to do what it does. Just because you have math that says this thing would mathematically be possible doesn't mean it actually is.
Yeah.
Now, on the other hand,
Possible.
Dirac said antimatter. People said you're crazy, and then they found.
Yeah.
Other
Well, I
ones.
mean,
So-
math says you can have negative volume,
Yeah.
but I wouldn't know what that means,
Ha!
Yeah.
right? I mean, Helios 575. Helios is just like question.
That's a good.
I think it's because Athena's here and they have like the same god pantheon.
It's that backdrop, yo.
yeah.
Maybe
Yeah.
it's
It
from Helios
makes
this
it.
year.
Well, I have a guy who actually does some thumbs for me. He wants me to eventually highlight that so he can get a frame review. I guess he wants to make a video, and he wants to have that backdrop. So I'm going to try
Of
to do
this?
that in
Okay,
Skype.
take a screenshot.
Well, I think he
No.
wants to do it too, but we'll see here. Helios asks, since everything we see from space is in the past, how possible is it that there exists life, but we are looking at the planets prior to their evolution?
I love that question. I feel like that's super possible. That's extremely possible, and that's a really plausible question. There's probably so much out there that then this ties in with the Fermi's paradox, where we might have like just missed a civilization that had already evolved technologically and then already died out somehow. Either they killed themselves, or that the star in their solar system or planetary system had already died. So we might have just missed that crossover, but we might be approaching that crossover. Who knows? If the human race can live long enough, we might eventually live to see some of these exoplanets that we found evolve, if they're in the habitable zone of their planetary system, to form life on it. And we might be able to catch that. I think it's a highly plausible question. And
I hope that happens
concern.
sometime in the future.
I hope so too,
Yeah.
especially in our lifetime. But
That's going to be. I'm telling you right here
Research.
now. The great question whether alien life exists is going to be answered the day after I die.
Ha!
No!
Oh,
I'm telling you.
God.
I'm telling you.
Wait.
Mark my words.
Are you saying you're the alien then?
I'm just saying that's my luck. You know what I'm saying? It's like the
It's
greatest
like
question
Murphy's
ever
Law,
answered,
yeah.
and it's going to be the day after I died, and I would have missed it.
It's one of those just my luck sort of
Just
things.
my
I'm
luck, right,
there with
exactly.
you.
Yeah.
The answer to the other question about the impactor stuff, there's a thing called a hit parade, and that's of objects that might hit us. And the highest stage on the hit parade right now is an object called 2010 RF12. On 2095, September 6th, around midnight UTC, it has a 1 in 17 chance of hitting the Earth.
Wow.
And
That's
now-
almost.
now-
That's
now-
pretty
now-
high. That's
now-
extremely high.
Now, the thing, of course, is that first what I say is that the diameter of the thing is about 7 meters.
Oh.
That's
Yeah,
about
but
eight-
still,
eight-
it'd be nice
and-
little-
But on
you
the other
see it.
hand, given its velocity, its current impact velocity of 12 kilometers a second, you would end up with a yield of about 6 kilotons.
That's
Or
pretty cool.
9 kilotons.
That's okay.
That's
But still,
about half of Hiroshima type.
Well, how much was
type
how
bomb.
much was the energy released from the one that went over Russia not too long ago? That was pretty substantial. That was like
That was half a kiloton or 1
Half a
kiloton.
yeah, that's pretty substantial. Now I could tell you this, and I know we got to get going here soon, but in Utah, where I used to have clear skies, we would watch meteor showers, and I am not kidding. And more than one occasion, it was so clear that you could actually see meteors not just burn up in the atmosphere, not just have a little blue white light. You could see the actual white dust that forms behind them clearly.
Isn't that fun?
Wow.
And if you take
It
your,
looked like it fell right there. I mean, it looked like it was falling right in front of you. It was so
Yeah.
close. It looked like.
So Steve,
Yeah.
if you then take a good pair of binoculars and look at that tail, long after it's there, you'll start to see that tail start to move, because that's the little charged particles that start moving in the influence of this magnetic field.
It's
and you
so
start to see
weird,
the
though, 'cause-
twisty thing. But you got to take a binoculars and go up to that tail and watch it.
But these are up in the ionosphere, and yet
Yes.
it seems like it's a mile away.
Yes,
It's not clear.
But
Well, did you
look
yeah.
look at the tails afterwards, after the stream's gone by. They're really fascinating on how those ions move in the ionosphere.
Yeah.
Well, like a week ago, there was a meteor that passed right over Missouri. Did you guys see that one? It was
Yeah.
like
Yeah, I heard
250
about that.
pounds.
Right by the arch.
Yeah.
Was it
Right.
St. Louis? Yeah, I saw the arch in St. Louis.
Yeah.
Yeah, Missouri.
yeah.
I saw that. It was nice. Yeah.
And you know what's crazy? It was about a week before that. I had met some people out here that were talking to me because, we started talking about space and stuff. And they didn't have a background in science, but they were like, I saw aliens when I was younger. And I'm like, tell me about your experience. And they were just like, yeah, we saw a UFO fly over, and I swear it was like green and bluish and then had a whitish color. And I showed them that video and I said, did it look like this? They're like, oh, that's it. How'd they get the footage? And I was like, this is
Yeah,
a
was it?
meteor. I'm like, this is actually what it looks like. They're like, since I was 12 years old, I thought that was a UFO. And I was like, this just reassures me why I'm glad that this stuff is becoming more in the public ie.
Absolutely.
Because so many
Well,
times.
Athena was unidentified for them, so
It was
Yeah, okay, fair enough.
True, but then they called it aliens. So
I'm not saying it's aliens, but aliens.
we should build a wall to keep out those UFOs, right?
Let's get to can we get to 100 likes on this? We're so close. I know we got a lot of people watching, so maybe we get 100 likes on this, and make sure that you're subscribed to their channels. It is in the video description, so there's no excuse not to subscribe to their channels. But I know we got to start wrapping it up. It is getting late, and I appreciate you guys coming in. We're going to be doing this more often. I know Landon has been a busy guy, and we haven't done too many DEFCON 1 science, but hopefully we can start doing more. And obviously Athena's welcome back anytime. John's going to be busy as can be here, but I'm going to try to persuade him to drop by when he can.
I would love to, yeah.
We would love you guys.
By the way, I should also mention the most deadly item on the 21 potential impactors is a thing called 1950 DA. It's 1.3 kilometers in diameter. And in the year 2880, it has a 1 in 8,300 chance of hitting the Earth, which means it has a 99.988% chance of missing. But if a 1.3 kilometer object hit the Earth, it would be bad. Very
bad.
Very, very, very bad. We're talking about 75 gigaton.
Planet killer.
Yeah. So what we
What is
have
it?
is not until the year 2880. It's called night.
Okay.
Well, the object object is called 1950 DA.
Wow.
Yeah, we'll probably have a gamma ray burst by then. It does.
Yeah. And remember, those are just the ones we know of. Imagine, like, of all the ones that actually, like, literally exist compared with what we know of, it's going to be it's a huge ratio there.
Yeah. People are like, no, keep going. But the thing is, like, I try to keep these down so people can watch them later on. People don't watch, like, 2-3 hour videos any longer. They kind of, like...
Wait, we are at an hour and 40 minutes?
Yeah, already.
Oh.
One of my jobs is actually keep track of time, platonic or real.
It's like dark out here.
Whether it's platonic time or Platonistic or reductionist time for us passes. So,
but anyway, so thank you for that background, and folks in the comment section, tell me about what that background is. Tell me about what you see.
Let me make the speaker.
Where would it be? All that sort of good stuff. Tell me about that. Put in a comment section. Describe the planet. Does it have an atmosphere? What is that object? What are the nebula? What's right? What's wrong? Where it might be? Tell us about that.
Talk to us, Athena, so actually it highlights that so people can actually see the actual image.
Wait, what?
Talk to it, because I put it on speaker view. So talk. So it actually shows the.
Describe.
Yeah.
Oh, okay, because you want to actually see me. Okay,
Yes.
so like, describe this image. What is that? What is this? I'll do a Vanna White hands. Is that a staircase? Why is it there? What is strange about this image? Is this actually scientifically accurate? Highly doubt that, but it's up to you guys. Leave it in the comments. Let us know.
Yeah, see,
What's going on?
that doesn't look like a planet. That looks more like something like what I would imagine a brown dwarf to be, or something.
Tell me about the crescent of that maybe that moon or that star. What's shining? What's causing the crescent to occur? Is there another star over there? We're not being
Some illumination that we're missing.
Yeah. What's going on?
Here you go.
I don't know. Check it out.
Oop, I don't want to
Check it out right here.
There we go. Boy, we have the weirdest things. Okay, so anyways, like I said, we're gonna have to be wrapping it up.
And you guys said I didn't need to hang it up. I'm so
I
happy.
know I did. I told you to
Look at that,
whatever
Steve.
you wish. I think it was a good idea. It just was just fascinating watching you actually put it up. It was a project. Yeah, it was like nothing, and all of a sudden, boom, cosmos.
Yes.
Yeah. So let's chill each other out real quick. You know what, Dr. Kroon, why don't you go first real quick, because you got a really good astrophotography thing. People don't really know much about it. It's a shame, because your photography stuff is just magnificent.
I'm trying to. I'm always trying to change up the way I convey and produce and edit and mix my videos. I'm always open to new ideas. I'm always thinking of new things. But the essential goal is to inspire people to, if they haven't already, to think more about the universe, to see that you can actually take pictures of nebulae and galaxies from your backyard and suburbia. And also to give some tips and tricks to those who are already doing so, and also to document my travels so that I could keep a record for my own self as well. And it's a lot of fun to mix in some cool pictures and some neat music.
They're
with
amazing.
My travels.
Just amazing.
So I hope you guys enjoy that. My latest one actually includes 3 nebula. Usually I only drop 1 picture. This one's a 3-banger, so I called it Nebulae Galore, and it actually comprises 2 astrophotography trips within a week or so of each other.
Do you know what I'm envious for? Is that you have all the good stuff that you could actually do all that stuff with. I had a telescope. I don't even have any oculars for it any longer. It's that old of a telescope, so I can't even use it. But I used to be able to, when I did have a decent sized telescope, like 4-inch, it would take me forever to find anything. Even though when I knew something was, right? With his stuff, he just like types it in. Bzzzt, there.
Steve, I could
I've got scope
about how to improve your setup. I would love to.
Well, I don't have a telescope now. I mean, mine's just a furniture piece now because I have no oculars for it, and it's just really old.
That can be fixed.
What did you mean any good? I live in a place right now that has too much light pollution. So
there are ways around it.
Do radio at astronomy.
I put out stars in the middle of the city.
No, I mean, on a clear night here, I can go about, I don't know, maybe a couple hundred meters that way and be in a clear area. And during the wintertime, it's exceptionally clear here. So I shouldn't say that there's probably no place I can go. But one of these days, I'll invest in another telescope and do it the right way, where I have it where I could actually put information in and kind of go there. Because I love, one of my favorite things for me to look at, obviously the Orion Nebula, like Athena was talking about. I would love to look at that and watch literally satellites go across my field of view, and the trapezium, and stuff like that. But the other one is the double cluster. I can always know where the double cluster is with respect to the other, because it's like circumpolar.
Perseus and Cassiopeia. It's right in between those. Yeah, I have a picture of that too.
So I could find that in Andromeda those I can find pretty easily, and the Beehive cluster I can find pretty easily, but the rest not so much. But by the way, your mom liked the show.
Oh, cool.
I appreciated that.
Hi, Mom.
Hi, Mom. All right, so Athena, what do you want to show for us? I know you already kind of did earlier, but do it again, because people got to go subscribe to your channel. It's in the video description, so go to her channel. She's going to probably do a follow-up on this involving her Trappistry. Hopefully she'll link this video. Send me a few subs too, but
Yeah, definitely. Well, now that I have this thingy up, yeah, I mean, well, right now, not only on my YouTube channel, but my website, I'm building quite a few things on there on Astroathens.com. I've got like a launch ticker at the bottom for like different rocket launches coming up. I'm actually heading out to France in a couple of days to do coverage for the Ariane 5 rocket launch. So I'm pretty stoked for that. So I'm going to be sharing quite a lot of these things like as they're happening. So not only stuff in astrophysics discoveries, but also things that are leaving our planet and going to space, working on, revisiting the lunar surface and eventually going to the Martian surface. So my whole website, my whole YouTube channel is really based around just making space accessible to every single person out there. And whether you have a background in, PhD, or you are in the fashion industry, I also happen to be in that. I want to make it where we can merge those worlds together. So that's what I'm doing.
All cards on the table. She literally is an international model.
Yes.
So international model and space guru. I mean, this is what I'm saying. How she doesn't have 1 million followers by now, I don't get. But one day she will. I'm riding her coattails. So one day when she gets 1 million subscribers on YouTube, and somebody says, "Hey, remember Steve McRae?" She won't go, "Who? New YouTube channel. Who dis?"
Like the backdrop, yes.
The backdrop. There you go.
Big episode where they
it's okay.
tape it up.
People get famous and forget all about me. It's quite all right. I understand it. But speaking of famous, we have like one of the premier mathematicians, my co-host Landon. Landon, what do you got going for you coming up here? And you wanted to talk about something else too, by the way.
Well, I mean, I don't want to think about it at the end, but one of the things is I am going to be traveling to Australia, allegedly. That's joke, folks. Where it's part of Square Kilometer Array, but also some other astronomy stuff. But the cool thing is I get to look at half of the universe that is sort of hidden from me, right? I get to go back and look at one of my favorite objects that's not a planet, Eta Carina. Amazing star pair with really weird stuff there. I hope someday it goes boom. Get to watch it, because that would be a really cool thing. But yeah, so the Southern Stars and Australia train trip, going out because they have maybe the third or fourth best skies on the planet, and to see those Southern Stars will be a glorious thing too. Also, the response back to Google: if you want to hire me, it's got to be for something audacious. I've told you the thing I want to do is put a telescope on the moon, right? Why do I want to put a telescope on the moon? Because when the sun sets, I want to be able to look without an atmosphere, within like a few tenths of degrees from the surface of the sun, look for asteroids orbiting inside the Mercury's orbit, right?
That'd be
and the way you do that is you put a telescope on the moon, and twice a month you can see
I'll tell you what. I think I might be in Dallas Fort Worth area, January 2nd to the 6th. Sweet Heathen and I want to go on a little vacation. We thought about going to that area, and I'm sure there's a lot of clear skies up in that area. So maybe if John's available, maybe we can find someone down there with a telescope and maybe kind of have a live stream, and he can kind of walk us through and say, okay, point it here, point it there. I would love to do something like that, because Texas is going to be a lot clearer than it is here, I'm sure.
Yeah. So again, please subscribe to Steve's channel, because he's got great stuff, content there. Right, Athena's channel as well on there, and so forth. Also, I want to say, just about a sadness, those that know Pimp Monk, John Colley, his father died today. And so if you can possible with something rather, or need some sympathy, that would be appreciated.
Yeah, Pimp's a good man. Known Pimp Monk a very long time. He's also occasionally a co-host on Drunken Peasants. Like I go on Drunken Peasants, and so please go see what you can do to help out Pimp Monk. Yeah.
But please keep asking questions and enjoy this favorite universe.
And I appreciate everything. I appreciate all my Patrons. Patreon is linked in the video description. That's what makes all this possible. I've been trying to put out a lot of content, but it's been difficult because of a lot of different reasons. But we are going to be doing a lot more stuff like this. I got still Ask a Philosopher, and I still got a lot of people that want to come on, but I'm kind of saving it for hopefully the relaunch of the Non Sequitur show one day. So we'll see what happens, guys. But I appreciate everybody who's been supportive. I mean, just the outpouring of support for me and the people that we've had on and their channels has just been immeasurable. And I thank you guys from the bottom of my heart. With that, I especially want to thank Dr. Kroon and his mom coming in. Love you.
Thanks, Mom.
Yeah, thanks, Mom, thanks, Mom, for allowing your son to join us. You got parental permission. Good night, guys.